5.7 line of best fit or Scatterplots trend lines, Algebra 1. We're going to talk about correlations between data. We're going to talk about lines or curves of best fit. We're going to be able to make predictions based on the data given, and we're going to talk about scatterplots in this section. All right, so the first thing we're going to talk about are scatterplots. Scatterplots are a graph that relates two different sets of data by graphing ordered pairs in a coordinate plane, and that would be quadrant 1 only. They are used to find patterns or correlations in data. So we're only going to be talking about one quadrant of the 4, and the 3 types of correlations are this one right here, which looks like a positive slope. That's going to be a positive correlation. This one right here is going to be a negative slope or a negative correlation. And this one doesn't have any, so that would be no correlation. Positive correlation exists when the x and y values both increase. And an example would be like the more money you make, the more taxes that you pay. Both of them go up, both of them increase. A negative correlation exists when the x value increases and the y value decreases. For example, the more people that download music, the fewer CDs are bought. Okay? And then no correlation occurs when there's absolutely no relationship between the x and y values. For example, hair color does not have anything to do with how tall you are. That has no correlation, and that would give you a graph that looks like this. Okay? So positive when both x and y goes up. A negative is when the x increases but the y goes down. And then, of course, the no correlation, they don't have any kind of pattern at all. Right? TI-83 instructions. Okay, so the first thing you want to do is I'm going to pull up my TI-83. And, all right, when you're doing this, you're going to want to always come into class and make sure that all these things are right on your calculator, because the other classes may have something else on there. You need to make sure it's right for you. And this is good practice for when you take your standardized test. You want to turn the diagnostics on. So you hit second, and then you go to catalog. Second catalog. Why is it not working? Second catalog. Why isn't the second button working? Hold on. See if I can work it from here. Second catalog. Alright, so you want to scroll down to diagnostic. It's alphabetical order, so it may take a few minutes. Diagnostic, and you see this one that says diagnostic on. You want to click on that, hit enter, and then hit enter. And when it says done, then it means it's on. Okay, so now you're ready to roll. Alright, so you need to have that on your calculator at all times when you're doing this work. Alright, I'm going to move this out of the way. Alright, so then what we're going to be doing is we're going to be entering data. And so when you enter data, you always will go to place it into a table. And that would be, first you would press stat, number 1, and edit. So I'm going to go ahead, and this information down here in example number 1, I'm going to go ahead and do that and show you where it's going to go. Okay, let me bring that back up. Alright, so you go to stat, which is right next to your left-right button, stat, and you hit edit, number 1, enter. You're going to find the 2 tables. Now, if for some reason they are full and have things in them, you just roll up to the top. Notice I push up to where I highlight L1, and then you hit clear and enter. And if you wanted to do the same thing to L2 or any of the ones that have things in it, you hit clear and enter. Okay? Alright, so we start at L1. I'm going to go ahead and type in the information in example 1, so when we get started on this, it'll go really fast. Every time you have a table, the first row is considered your X or L1, and the second row is L2, and so on. So I'm going to type in all my L1s. So this is going to be 4.75 and hit enter. Okay, and then the next one on the same row is 6.84. Hit enter. Next one's 12.52. Enter. Let's see what this one says. Move this out of the way. 20.42. Enter. And then 8.97. You hit enter. Now, you move over to the next column by moving the left-right button, moving over to the right, and you type in your L2 stuff. So that's going to be 0.50. Enter. 0.90. Enter. Move it back out of the way. 1.5. Three. And 1. Okay, now it's very important to make sure that you have the same number of items in the L1 column as you do in L2. If not, it's going to give you an error. Okay, you have to have equal number of items in both columns or it's going to give you an error. Alright, so we've got everything in. We typed in the values into the list. Next, you're going to find the line or curve of best fit. And that would be stat, calc, linear regression number 4. So you go from here, you go stat, and up here where it says calc, then you go to linear regression number 4. Hit 4, and then you hit enter. And it's going to come up with all these numbers, okay? Where it has, at the top it's got y equals ax plus b. I'm not sure why our calculator has a instead of m, but this is slope-intercept form, so it's really mx plus b. So a would be your slope, and b would be your y-intercept, okay? So you would just round these. We're going to round them to like 0.157, okay? And then b would be like negative 0.3 because it's 299. So we're going to round those and put those up there, okay? Round them out. Go about 3 places out. And that's where you're going to come up with your slope-intercept form equation, okay? Now, you also notice there's an R2 and an R, okay? The R is your correlation coefficient, okay? That's going to predict how well the line fits the data. If the value is a positive correlation, the closer it is to 1, the stronger and more positive the correlation is. But if the value is a negative 1, where R is, then that means it's going to be a strong negative correlation. Again, the closer the number that this R value is, just the R, not the R squared, but the R, the closer it is to 1, and this is 0.99, so it's pretty close, the better the fit, okay? If it was 0.2, that means it's not a good fit, and that means that equation wouldn't fit with most of the data. All right, so this one's pretty close. So if we were going to write this equation for this information, which we have already done in example 1, we can already type in, we've got the equation. See if I can write this down before it goes off my screen. Just as soon as I do this, it will go off my screen. I'm going to have y is equal to 0.157x plus negative 3. So we'll just have minus 3. Minus 3. Alright, so I'm going to type that in right here. Or write that in right here. So it'll be y is equal to point. And in this section, it'll be okay to have decimals because that's what the calculator is going to give you. X minus 3 because it was a negative 0.29999. So it should be, I guess, 0.3. Let's look at that again, make sure. Yes, it's 0.2999, so that means it's a negative 0.3. Okay, you're going to use that equation to figure out the next question. All right, so let me move this out of the way. All right, so in this equation, a student who waits on tables at a restaurant recorded the cost of meals and the tip left by diners. Okay, in the next diner, if the next diner orders a meal costing $10.50, how much tip should the waiter expect to receive? Well, based on this equation, we can find out how much they should expect to receive based on this. So what we just found is the equation for this setup. So the meal cost, $10.50, that would be up here in this. This is, remember, what we consider our X. And this is what we consider our Y. So we're going to take and figure out, when we plug in right here, $10.50, about how much our tip should be. So that's going to be Y is equal to 0.157 times 10.50. Whoops, I'm running out of room. 10.50 minus 0.3. And that should tell us how much money we should get on tip. So let's go ahead and get my calculator back up. And I will do, type this in. So it's going to be 0.157 parentheses $10.50 minus 0.3. Enter. So that is saying that we should get $1, and rounding to cents, that should be $1.35. Okay, $1.35. So that should be in tips $1.35. Okay, so that's what they should get if they the diner has the amount of $10.50 based on this equation, and that doesn't mean that that couldn't be a little bit more or a little bit less, but this is a pretty good indicator of how much based on the trend. So it should be about $1.35. All right. The next one says, this table shows the gas mileage ratings for different cars in a year. The engine size, L, is in liters of displacement. The mileage, M, is in highway miles per gallon. So we, again, will remember this will be like our X. This will be like our Y. All right, and we're going to figure out if this is going to be a positive or negative correlation. So I'm going to graph this. I'm going to have to set this up a little different because we have really high numbers on our dependent side. So we're going to have to spread these out a little bit. Okay, and then this I'm going to go up 5, 10, 15, 20, because you notice our numbers go pretty fast. 25, 30, 35, 40, whoops, 45, 50, 55, 60, 65. I think it covers all my data. All right. So now notice that the points are scattered, not all in line. So when we graph this, at 1, it says 58. So let's go up here to about right here. At 1.5, it's going to be at 52. About right here. At 2, it's about 47. At 2.5, it's about 40. At 3, it's 36. And 3.5, we're looking at 32. So looking at this trend, is that a positive or a negative correlation? It's going down. If you're reading left to right, it's going down. So this would definitely be, whoops, a negative. I'm running off my, let's fix this. Running off my little tablet here. A negative correlation. Okay? So notice that the points are kind of scattered. Not all in a line. If you draw it, it's not exactly a line. This is called a scatter plot. And to approximate the equation of these points, we use a line of best fit that most of the points will fit into. And it's called the line of best fit or trend line. The equation of this line is used to predict other points. So once you put this in here, you have to draw a straight line. Some of it would fit right exactly in there, and some of it would be really, really close. You may have a few points outside, but most of the data would fit on that line, right? So you can put these in your calculator and make an equation, just like we did before, if that's what it asks you to do. Sometimes it'll just ask you to graph it. Okay? So we're going to be practicing with these in class, going back and forth. I'll give you a piece of paper with the steps on how to do the calculator stuff. Main thing is to make sure your diagnostics is turned on every class, okay? And we're looking at the R value and the equation. And again, it'll show A, but that's the same thing as M, and we can make an equation from there. If you have any questions, come see me.